Hi, everybody. Now we're going to do section 1.2. So let me share my screen with you, and here we go. So this is 1.2 graphs of equations. So we have an equation. This is a famous equation that connects Fahrenheit and centigrade. And now we want to look at a graph y equals 7 minus 3x. I'm sorry, 7 minus 3x. So one way to sketch a graph is to, let me put this over here. One way to sketch a graph is to plot points. So if x is 0, y is 7. If x is 1, y is 4. If x is 2, y is 1. So on, because you just take the value and plug it into here. This is 7 minus 0, which is 7. This is 7 minus 3, which is 4. 7 minus 6, which is 1, and so on and so forth. And once you have these points, you plot them all like this. Pow, you got your line, straight line, beautiful. And this, again, is something I'm going through a little quickly because I'm assuming you've seen this sort of stuff before. And now we go to another equation, y equals x squared minus 2. Now, some of you geniuses probably know this is a parabola. But again, you plot points. If x is negative 2, you plug that into the, let me get this out of here. If x is negative 2, then I get 4 minus 2, which is 2. If x is negative 1, I get 1 minus 2, which is negative 1. If x is 0, I get negative 2, and so on and so forth. And when I plot all those points, I get these points right here, which, if you fill it in, becomes a parabola. And that is the story with that. Parabola. And anytime you have an equation, y equals ax squared plus bx plus c, it's always going to be a parabola. That's a standard thing. All righty, let's move on. Now, the intercept means you want to know where the graph hits the axis. This is the x-axis and or the y-axis. So this graph over here hits the y-axis, never hits the x-axis. This hits the x-axis 3 times, hits the y-axis once. This hits the y-axis twice and the x-axis just once. And this doesn't hit any of the x-axes, I don't know how you pronounce that. So how do you find these guys? If you want to find the x-intercept, set y equal to 0 and solve for x. If you want to find the y-intercept, set x equal to 0 and solve for y. That's it. This says it all. This says it all. So we have y equals x to the third minus 4x. So to find the x-intercepts, I set y equal to 0. So I get x to the third minus 4x equals 0. I factor out an x. I get x times x squared minus 4. Then I factor x squared minus 4 into x plus 2x minus 2. It's the difference of 2 squares. And now this gives me x equals 0, x equals negative 2, or x equals positive 2. And that's going to be the x-intercepts of the graph. And now to find, if I plug in x equals 0, negative 2, or positive 2, so here I get 0, 0, negative 2, 0, and 2, 0. Notice that the y value is always 0. That's by definition. Now to find the y-intercept, set x equal to 0 and solve for y. Well, if x is, that's easy. Set x equal to 0, so you get 0 minus 0 equals 0. So if x is equal, so it hits the y-axis at 0, but if y equals 0, x equals 0, and we actually got that same point there. So that point, this point here, is an x-intercept and a y. It's the origin. It's an x-intercept and a y-intercept. It's both. But these are the 3 x-intercepts. That's the 1 y-intercept. Notice that the 0, 0 intercepts both. Now let's talk about circles. The equation for a circle, if the center is the point h comma k, so that could be 2 comma 3 or whatever, and the radius is some number, we'll call it r. The formula for the circle, the formula for the equation of a circle on a graph is x minus h squared plus y minus k squared equals r squared. So h comma k is the center of the circle, and r, which is always a positive number, is the radius of the circle. Because the radius is a physical thing. And if you have a circle whose center is at the origin, Oh, I can't believe I sneezed on the air. Now my sneeze is going to be famous. Then x squared plus y squared is going to equal r squared if the center is the origin. And this is a formula you may have seen a lot. So let's say we have we have the point 3, 4 lies on a circle, and we know the center of the circle is -1, 2. So what's the equation? Well, notice that it doesn't tell us the radius, but we can figure out the radius by knowing the center and knowing that point, and we use the distance formula. So the distance formula, if I do 3 minus -1, then square the whole thing, and then 4 minus +2 and square the whole thing, I'm getting the numbers from here. 3 minus -1, and that's 4 minus 2. And that gives me 16 plus 4, which is 20. So the R is equal to the square root of 20. Excuse me, R is equal to the square root of 20. And now if I plug, now H and K, the center is -1, 2, because that's given, that's the center. So I get x minus -1, which is x plus 1 squared, plus y minus 2 squared is equal to the square root of 20 squared, which is just 20. And that is the equation for the circle. That is the equation of the circle. So there you go. See how much fun that was? And here we have if they have an ordered pair, which is a solution of two different equations, then they call it a point of intersection. So for example, the parabola here is x squared minus 3. The line is y equals x minus 1. These 2 points, that point there and that point up there where the red parabola and the blue line intersect, that's the point of intersection. And to find that point, since they're both equal to y, I set them equal to each other. So x squared minus 3 is going to equal x minus 1 because I'm setting the y value, y equals y. So now I'm just going to solve this for x. And this is actually a quadratic. It's not that hard to solve. It doesn't solve it here, but it's actually not that hard to solve at all. You just have to bring everything over to one side and solve it like a quadratic. I can't believe they're not solving it. That's so rude. Anyway, let's move on. Find a break-even point. A company I can't believe I'm not doing this. Let me just think here for a second. How can I do this with so we have x squared minus 3 equals x minus 1. Bring everything over to the other side. I get x squared. I get x squared minus 3 minus x minus 1 equals 0, but that cleans up to be this. Let me just so that's going to be and then this is something which I can factor. This is easy to factor, and that's because this is x minus 2 times x plus 1, x minus 2 times x plus 1. So that's how I get. So the intercepts are going to be 2, -1. Those are the intercepts. There you go. It just bothered me not doing this. I say. So there you go. Let's go back to our. Oops. Let's go back to our textbook. Okay. So break-even point. A company manufactures a product at a cost of 65 cents per unit and sells the product for 120 per unit. The company's initial investment to produce the product was $10,000. Will the company break even when it sells 18,000 units? How many units must the company sell to break even? So the total cost of producing X units of the product is given by cost is equal to 0.65x, because each unit is another 65 cents, plus the fixed cost of 10,000. And 10,000 that's no matter what. Now the revenue is 1.2 times X, because every unit that they make or that they sell, they get $1.2, $1.20. The break even is when the cost is equal to the revenue. So R equals C, that's 1.2x equals 0.65x plus 10,000. Now you just solve this, you bring the 65, subtract the 0.65x from both sides, you get 0.55x equals 10,000, divide by 0.055, you get x is approximately 18,182. So when they sell about 18,000 units, roughly, that's when they're gonna break even. And which means they break even means they don't make any profit, but they don't have any loss. The profit comes when they sell more than 18,000. So that's the thing. Sometimes it takes time that's the same business. Sometimes it takes time to see a profit. Okay. Pharaoh's daughter saw the profit by going down to the Nile. Oh, see what a joke that was. Two types of equations that economists use are the supply equation and the supply curve. There's also the demand equation and the demand curve. So when supply equals demand, that's equilibrium point. So the demand and supply equations for an ebook reader are P is equal to 195 minus 5.8x, that's the demand equation, and P equals 150 plus 3.2x is the supply equation. So P is the price, and notice when the price increases, the demand decreases, but when the price increases, the supply increases. So it's kind of interesting. So where P is, X is it represents the number of units, the number of units sold in millions. So find the equilibrium point for this market. So basically, you have to set the demand and the supply equal to each other. 195 minus 5.8x equals 150 plus 3.2x. Subtract 150 from each side, add 5.8x to each side, and I get 45 equals 9x. Divide everything by 9, I get x equals 5. But 5 means 5 million. So the equilibrium is when you have 5 million of these suckers. So there you go. And that's the and that produces the 166 for each. So there you go. That's the that's when you have the thing. What was it? Okay. So moving on. Mathematical models. So this table shows the average crude oil production in millions of barrels from 2009 to 2013. And so this is what it was in each year. A mathematical model. Now, how they figure this out, that's another story. And that's a whole skill, by the way, figuring this out. And there's a lot of jobs of just figuring these things out. But that's y equals this funky equation. So what we want to do is we want to use the graph and a table to compare the data with the model, and use the model to estimate the crude oil production in 2014. That's why we want these. By the way, that's the key. So we have all these points, these years, by getting a good mathematical model that tells us that helps us predict what it's going to be in 2014. And predicting in business, knowing what's going to be is a very big thing. It helps you set up your whole thing. Anyway, so here's all the numbers. Now notice that the crude oil production was the actual numbers. The model is based on that equation. So they're not exactly the same, but they're fairly close. That's really the point. They're not exactly the same, but they're kind of fairly close. And you can see that this curve doesn't exactly hit every point because it's very close to each point. And that's sometimes you're not always going to hit the equation will not always hit exactly every value, but it comes close. That's the best you could do. And that's a good thing. Now all we got to do is plug t equals 14 into the equation, and we plug that in right there. We get 8.81 million barrels a day, and that's our prediction for 2014. And that is a huge thing. There's nothing bigger in business than predicting, what's going to be next year or what's going to be coming down the pike. Okay. Now there are certain basic graphs it's good to be familiar with. This is the graph y equals x. This is the parabola y equals x squared. This curve here is y equals x to the third. This here is y equals the square root of x. It's kind of the top half of a sideways parabola. This is y equals the absolute value of x. So you get like a V shape. And this is y equals 1 over x. This is this shape here is called a hyperbola. And so that's our summarize of section 2. And let's look at the homework. Okay. So I'm gonna put so this is the problems for 1.2. I'm gonna put the homework in I'm gonna put the homework in Canvas for this section, and these are gonna be the problems here. This is the various homework problems. I'll put the problems in Canvas. You'll see what they are, and that, my friend, is the story. So I hope you all enjoyed this, and it was loads of fun. Bye, everybody. It's been absolutely delightful.